section 5.2. And section 5.2 is corresponding parts is what it's called. But essentially, we are starting to get into the idea of the fact that congruency doesn't just work for segments and angles. It also works for polygons. Now, in order for polygons to be congruent, all of its corresponding parts must be congruent. So corresponding parts are essentially the matching parts from one shape to another. So in this picture here, I am told that AB is congruent to ZY. BC is congruent to XY. CD to XW. And DA to WZ. This is a quadrilateral. It's got 4 sides. If I want it to be congruent, all 4 pairs of sides must be congruent. And all 4 pairs of angles, which it also tells me that within this picture. Now, I can draw that in the picture as well, but it gets a little convoluted. It gets a little busy in that picture, but I could mark all of the angles congruent as well. Each pair of congruent segments, each pair of congruent angles is considered a corresponding part within congruent polygons. If you want to say polygons are congruent, you have to call them by name. And when it comes to calling them by name, triangles have a symbol for them. Bigger polygons do not unless they're a specific type. And so we would say something along the lines of, this is a quadrilateral ABCD. And we can say that that is congruent to the other one. But as I put it in there, I have to match up the order. I have to match up the corresponding parts. Angle A in this shape corresponds with angle Z. A is congruent to Z, which means since this name started with A, this name needs to start with Z. B was congruent to Y, which means Y needs to go next in this name. C corresponded to X, so since C was third here, X needs to be third here, and then D goes with W. They have to go in the same order. Now, each of these things, these little congruent things, those are technically called a congruency statement. Now, or a congruence statement. And the congruent statement, when we ask specifically for a congruent statement, most of the times it's going to be for the polygon itself. This is going to be the main thing that I'm looking for, but that's for this piece. It also says identify all the corresponding parts. So I'm also going to write these ones. Okay. To do this, you got to make sure you're matching up corresponding parts. Now, when you write the first side of a congruency statement, it does not matter what order the letters go in, as long as you're making your way around a shape, either going clockwise or counterclockwise. When it's a triangle, there is a symbol that goes for triangle, and it looks like a little triangle. So if I've got this shape, I can start at any of the 3 corners. Do you want to start at J, K, or L? I heard someone say J. And then you either go clockwise or counterclockwise around. Doesn't matter. You got to make a choice. I'm going to go clockwise. Triangle JKL is congruent to. Now the other one's also a triangle, so I put a triangle symbol. And now The order of the second one has to match based on corresponding parts. J corresponded with which angle in the other shape? You see the double congruency mark? Which angle has a double congruency mark? T. J goes with T. I went to K next. K was the triple angle. S. And the other one is the triple angle. Ends with L, which is the single angle, R. That is the congruent statement for the polygon. I also need to identify the corresponding congruent parts. A triangle, how many sides does it have? How many angles does it have? I have 6 corresponding parts that I have to mark are congruent in a triangle. I'm going to start with the angles. Angle J is congruent to angle T. Angle K is congruent to angle S. Angle L is congruent to angle R. Now, I can continue to look at the picture as we have been doing. Or, the nice thing about having a congruent statement is once you have the congruent statement, I technically don't even need the picture to know which ones match up. J was first, T was first, they're congruent. K was second, S was second, they're congruent. L was third, R was third, they're congruent. The only time it really becomes pickier that I need the picture is when the shapes connect, like this one, because if I talk about angle M, I can't call it angle M because I don't know what angle that is. That's when it gets pickier. If the shapes are 2 distinct shapes, I can always just use the names. That includes for the segments. That includes for the sides. Because if I want to say, if I didn't know anything about the picture, I'm going to move it off screen. If I just knew this, I have to know that one of the sides is JK because those two are right next to one another in the name. Since it's a segment, I put the bar above it when I talk about it by name. JK are the first 2 letters. First 2 letters in the other ones are TS. Hello. Hey. Yes. Yeah. Yep. Yep. Bye. What did you do to get in trouble?
Where am I supposed to go?
Katie wants to talk to you.
Okay.
Okay, anyway, back to our problem. So, JK goes with TS because they're the first letters. Which one would KL go with? KL are second and third. SR are second and third. Now the last side of the triangle, when it comes to a triangle, it has to close itself, which means if you're just using the name, the first and the last letters of the names will create a side length on a polygon as well. So LJ is congruent to RT. Now, here's the thing. Could I have used the pictures and looked at the tick marks? Absolutely. There's nothing wrong with that. I'm just saying there's another way because there's going to be some times where you're not given a picture and you are just given the congruency statement. Or the picture won't have tick marks on it. Okay. There's our triangle. Next one. How many sides does that shape have? 4. How many corresponding parts will it have then? 4 sides and 4 angles. 8 corresponding parts and then the congruency statement. So sometimes these can get a little bit tedious to write out. I promise you're not going to get a whole lot of problems that ask you to write out all of these. I'm not saying you won't get any, but a lot of the times it's going to shorten down the problem or you're going to do something else with it. Okay, when it comes to naming a shape, again, I do not care which corner you start with. I do not care what direction you go around the shape. Make sure, though, that you are going either clockwise or counterclockwise. I could not call this polygon ACBD because AC is not a side of it. Let's say I want to go ABCD. Bigger polygons don't have a symbol that goes in front of them, so you just go with all of the letters of all the corners. ABCD is congruent to. Piper, if I started with A in this shape, what letter am I starting with over here? E, because A had 3 angle marks, E has 3 angle marks. Peyton, I went to B next, so what letter should go next in the other one? Yes, 2 angle marks, 2 angle marks. Now here's the thing about these though. I started at E, I went to F. I also have to go either clockwise or counterclockwise around the shape. Can you tell what direction I'm going? I started here, I went here. I'm going counterclockwise. Now you don't have to know by name if it's counterclockwise or clockwise, but can you tell that the next one you'd have to go to if you started here and went here would be G? Once you know what direction you're going, go ahead and just keep going that direction. You don't have to keep matching up. Well, C went with G and D went with H. Can you? Absolutely. Do you have to? Again? No. Okay. Now we need those corresponding parts. I got 4 sides. I've got 4 angles. Haley, Bakken, could you tell me about one pair of corresponding angles in this shape? Corresponding means they're the ones that match up. They're the ones that are congruent. So if I start with G and C. Okay. I'm going to start with C instead of G, but you're 100% right. Angle C is congruent to angle G. And I'm starting with C just because angle C comes from shape ABC, and it helps me make sure I got them all if I just kind of keep some sort of a pattern going for me. Brody, could you tell me about another pair of congruent angles? Pick any angle in here other than C. Angle A. Angle A has 3 markings in its corner. In the other shape, which one has 3 markings? Yep. A has 3 markings in its corner. Which angle in this shape has 3? There you go. Angle A with angle E. Zion, could you tell me of another pair? Angle B is congruent to angle F. You're 100% right. Which leaves me with angle D and angle H. Now, do you notice that the sides are not marked as congruent? Now, if the sides are not marked as congruent, what you do from there depends upon the problem. This problem said write a congruency statement, which means it's implying they're congruent. If it does not have something in the instructions saying they are congruent polygons, there is no guarantee that they are congruent. This one is implying they're congruent, so they have to match up. Now, to match up which sides with which, you can either use the names or you can use the relationship of the sides to the angles in the picture. For example, the side AD, do you notice it's between the triple and the quadruple marked angles? In this picture, the side between the triple and the quadruple marked is this one down here. Those must be congruent. AB, which was between triple and double, matches up with EF between triple and double. BC between double and single goes with GF between double and single. Last but not least, between single and quadruple is that one and this one. The congruent sides must be between the same two congruent angles, and vice versa, it works that way as well. The angle between the single and the double marked sides is E. Between here, the single and double is A, therefore E and A had to be the congruent angles. Anyway, I have to actually write the statements though. AD was congruent to EH. DC was congruent to HG. BC was congruent to GF. And the last one was AB being congruent to FE. What did I miss on all of these? The bar above. Don't forget the bar above. All of these are segments, they all need the bar. One other quick note about the segments. When we did the first one, this triangle, we did the segments by doing first, second, second, third, and then last, first, and we matched up the letters perfectly. On the segments, technically, as long as you're using the right two letters, it doesn't matter what order they go in. A, D, E, H matched up. But for example, I know at least one of these I didn't match it up the same way. Which one was it? Like these ones, B, C, and GF. They are congruent. I said B, C, and GF, which means I went from double to single, and then I went from single to double. Technically, in the segments, it doesn't matter as long as it's the same two angles. As long as it's the correct two letters. Okay. A lot of the times you're not going to be asked to write all of those little congruency statements. Sometimes you're going to be given a congruency statement and asked to just finish it off. It's telling me triangle SQR is congruent to triangle KJL. If that is the case, angle S should be congruent to what angle in the other triangle? K. They're both the first letters. Now, when you're given this, double check in the picture. Can I call that angle K, or do I need the three-letter name? If it's just the single angle there, can I call it K? Yeah. Angle K. And don't forget the angle symbols with angles. Don't forget the bars with segments. Angle Q should match up with what angle in this one? Q's in the middle. J's in the middle. Can I call angle J just by a J? With the angle symbol? Yes. And if you want to mark it in the picture to make it easier on yourself, you can. You don't have to. QR. That's a segment. Specifically, that's this segment. In the name, QR is there and there. It should go with JL. SR is the last one with this. If I look for S and R in the congruency name, it's first and last, which means it should go with K and L. So these ones are about using that statement. Okay. New congruency statement. Triangle NLM is congruent to triangle EMC. Starts off with angle L. Aaliyah, what angle does L correspond with? Angle M. Angle L in this triangle to angle M in this triangle. There's only one problem with that. If I look at this triangle, I can tell this is angle M, but can I use the single letter name? No, because if you say angle M, while I know that we're trying to imply that it's in the triangle on the right, by being inside triangle EMC, when you write out an actual congruency statement, it needs to be perfectly clear, even if I knew no other information other than what the picture looked like and that congruency statement. Which means I can't call that angle M. I have to use the three-letter name. Mariana, what's the three-letter name for that angle? This one. So M's the vertex, so that goes in the middle. This one. Okay. This angle is between this and this. So this goes towards, yeah, CME. Okay. Next one asks about angle LMN. LMN. Remember, in a three-letter name, the middle letter is the vertex. The other two letters tell you where the lines are going. Going towards L, going towards N, that's this angle. Ava, do you know which angle that would match up with? And that one's a little bit harder because we can't as easily use the congruency statement. But we still use the congruency statement. If I give you a three-letter angle name, I look for the three letters in here and I put them in the same order as the three letters in here. L was in the place of M. M was in the place of C. And N was in the place of E. M, C, E. It's this one. Could I have called that angle C? Absolutely. Is it easy to tell without the picture being marked? Not as much. Okay. Then I've got to move on to the segments. When I move on to the segments, I definitely look closely at that congruency statement. Okay. NL. NL, right there. NL, in the actual congruency statement, is the first two letters. Which means it matches up with EM. Because they're the first two letters. Next one's MN. That's these two letters. Aiden, which ones should MN match up with in the other one? CE, you got it. So, getting to recognize the congruent parts is actually probably going to be one of the most important things that we do in this chapter. Because when you know you have congruent polygons, you then know you have all of those congruent parts to work with, and vice versa. So, we can use that information to tell us the measurement of things. This one tells me quadrilateral ABGH is congruent to quadrilateral CDEF. Now, it didn't have to write the words quadrilateral on there. It could have just did ABGH is congruent to CDEF. This time, it's asking me to finish. What is the measurement of H? What is the measurement of FE? How do I know that that's a measurement and not the name of it? It's still capital. What symbol does this not have? The bar above it. Doesn't have the bar above it, and it also doesn't have a congruent symbol. Bar above it goes with congruent symbols. No bar is trying to tell me about the measurement. Okay, first one I'm looking for is the measure of angle H. Which angle should angle H match up with, according to the statements up here? H should go with F, because it's the last letter in each of them. What's the measure of angle F? 105 degrees, which means the measure of angle H is 105 degrees because they're congruent. If the shapes are congruent, the angles are congruent. Okay, it moves on to FE. Jackson, FE should match up with what side in the other shape? Yes, because FE are the last two letters, HG are the last two letters. HG is 11, which means FE is 11. Haley, angle G should match up with what angle in the other shape? Yes. Third letter. Angle E is 75, angle G is 75. Nate, FC should match up with which ones on the other shape? FC, HA. HA is 8, FC is 8. Okay, last thing you're going to see today is working with that exact same idea, but bringing it into solving. Bringing it into giving variables involved. In order to do this, you just got to make sure you're matching up the correct pieces. Now it says solve for the variables. In other words, there might be multiple variables in the problem. You got to keep an eye on the problems. This first one, how many variables do you see? Two. There's an X. There's a Y. The capital letters are not variables. The CM is not a variable. What does CM stand for? Centimeters. Don't be scared away by the units. I have that happen a lot. The people say, well, there's a CM on this one. How do I solve for CM? It means centimeters. Same thing with M. What does M stand for? Meters is what it generally is. Millimeters would be double M. Miles is MI. Okay. To do this, generally speaking, you want to figure out which one you want to solve for first. There's rarely a wrong answer to that question. Do you want to solve for X or Y first? X. Okay. X is right here. Where is it pointing that measurement is going to? Is it a side length or an angle? Angle, and its angle Y. Angle Y should match up with angle S. Those two angles are congruent. Therefore, their measurements, congruent's just a fancy way of saying what again? Are equal. 2x minus 20 equals 30. And then we're solving. I add 20. 2x equals 50. You divide by 2. X is 25. I'm probably writing off screen, aren't I? Not quite, but close. Next thing I'm moving into solving for is a side length. How do I know that's a side length? Not only is it next to a side, but do you measure angles in centimeters? No. It's got centimeters on it. Better be a side length. Okay, I got 3y plus 9. That is on side ST. Aria, ST should match up with which one? Yes, you're a step ahead of me in the question. But you are 100% right. ST should match up with YZ. YZ's right here, but it's not marked. But what Aria was pointing out is she saw these. That means those are congruent, which means the measurement of this one is 15. And since these ones are congruent, that means 3y plus 9 is also equal to the 15. Y'all know how to solve. Y equals 2. Next one says ABCD is congruent to EFGH. How many variables do you see? There's also 2 in this one. In fact, all 3 of these actually have 2 variables. Angle X and angle Y. On this problem, it matters which one you try to solve for first. Because if I try to solve for Y first, Y is connected with an X, and I can't solve a single equation with 2 variables. So I have to find X first. Angle X. Angle X. There's no angle X. Let's try this again. Variable X. That's what I was trying to say. Is right here. Is the 60 plus 8x an angle or a segment? No one's got confidence in answering that question? What symbol do you see on top of that parenthesis? A degree. Is a degree a side length thing or an angle thing? It's an angle thing. It has to be an angle. Which angle is it? A. Darnell. Which angle should it match up with then? GH isn't an angle. Angle A goes with angle. Same spot. First letter, E. Those angles are congruent, and congruent's just a fancy way of saying what again? Same or equal. Make sure you put the X on the correct thing. Far too often when we have a problem where the X is on the second term, people are automatically then moving it to the first term. It doesn't work that way. 8x equals 48. Divide by 8 and x is 6. Once I have x, now I can solve for y. Because y was here hanging out in angle G. Jada, angle G matches up with what other angle?
C.
Yep. Third letter. And if I go to write the equation 8y minus 3x equals 62, which is true, I get the hiccup of the two variables, but don't I already know what x is? X is 6. Can I replace x with 6? 8y minus 3. Remember, when you replace it, you should put it in parentheses. That way it takes care of whatever operation's happening. 8y minus 3 parentheses 6 equals 62. If I want to solve that, what do I have to do first? Diego, if I want to solve this, what should I do first? Multiply the 3 and the 6. Simplify before you try to solve. 3 times 6 is 18. Since it was minus, it's still minus. Y'all know what to do from here. You've shown me that. Every once in a while we make mistakes, but y'all know how to solve. I end up with y is equal to 10. And we have one final problem and then we're done. DEFG is congruent to SPQR. I have two variables. I have x and I have y. Because x and y are in the same equation, here I can't use this equation first. I have to use the other one, which happens to solve for x. 2x minus 4. That's on QR. Cam, QR should match up with what side from the other shape? Yes. QR are the last two. GF are the last two. 2x minus 4 equals 12. Again, at this point, you solve. I'm just doing that quickly because y'all know how to solve. The setup of the equation is the thing we're practicing. Okay. Yes?
Why'd they put the other numbers in?
Why'd they put all the other angles in? Because they will commonly do that.
Are they trying to like mess us up or something?
They're trying to make sure you're paying attention to which ones match up. Because oftentimes on problems, we've kind of been able to look at the shape and be like, well, it's the only other side available, let's just set them equal. Now that I've got the other angles there, which your homework will do the same thing, it'll have some of the extra stuff. Or are you paying attention to which ones match up? Okay. Next, last one. 6y plus x equals. Now that's angle Q. Charlie, angle Q should match up with which angle? Q is here. Third in the name. Third in the name is F. Q goes with F. F was 68 degrees. This, every once in a while, still tripping people up typically when I come to this is when we get into there, I see people are like, what do I do now? Kylie, what do we do to make this where I can actually solve it? Put the 8 in for the x. 6y plus. Since nothing's happening to the x, I can leave off the parentheses if I want. But don't forget you can plug it in. and then you solve again. Guess what? I got a worksheet for y'all today. I've also got a skill builder. I know, it's been a bit since we've done a skill builder.